Hi everyone, my name is Oliver J. Jones-Smith. I am the founder and head researcher at the Coniology Research Institute here in DC. I want to start by thanking each of you for taking the time to come and be here tonight. And I also want to thank Touchstone Gallery for the opportunity to share some of our preliminary findings from our research on the behavior and migratory patterns of traffic cones in the DC metro area. So, overview of what to expect tonight. We're going to cover 5 areas of our research. First, we'll start by introducing the field of coniology. We're going to talk about the aims of our research. Then we'll review the research methods and the ethical considerations that guide our data collection. After that, we're going to take a look at some of our research findings. And then I'm going to introduce some of the descriptive frameworks that we're developing that help us analyze and engage with the data. And then lastly, we'll talk about our plans for continuing research. So what is coniology? Coniology is an emerging field dedicated to the systematic observation and documentation of traffic cones within the, Coniology is an emerging field of scientific study that observes, documents, and classifies traffic cones, examining their presence, movement, condition, behavior, group dynamics, and environmental context. Origins of the field of coniology. So I moved to DC in November of 2025, and not long after moving, I noticed that the cones of my neighborhood exhibited some interesting behaviors. For instance, on February 7th, I noticed this particular cone, and then exactly 42 hours and 38 minutes later, I found this exact same cone approximately 20 to 25 feet away. Now, what I found particularly interesting about this case is that you'll notice in both photos, the cone does not appear to be actively in use. This gave me 2 questions. 1, what is driving this behavior? And 2, is that, are those movement patterns unique to just this individual, or are there broader movement patterns for traffic cones? I also started documenting and noticing that there are variations in the groupings of traffic cones in the area, as well as the ways in which they relate to one another, and how they engage with their environment around them. And this led to further questions about if there are other patterns with regards to behavior and grouping configurations. So after that, my immediate reaction was to see what research was available. And shockingly, when I went to look, I could not find a single piece of peer-reviewed literature, let alone a scientific study, which I found deeply perplexing because despite being absolutely everywhere, traffic cones are entirely unexamined and unstudied. This represents a major gap in research, which led to the formation of the Coniology Research Initiative to address this gap. And our main and only aim right now is to answer the question, what are the observable patterns and behaviors and migratory patterns exhibited by traffic cones in the DC metro area? So research methods and ethics. So in thinking about movement patterns and tracking that, the obvious first choice would be GPS tag and release. That would enable us to map the individual movements exactly of each traffic cone. And then that would give us like a complete and accurate data set that we could then analyze. However, implementation is stalled due to lack of funding and research. So in the meantime, we wanted to continue our research, so we went with the tools available, which include timestamp field photography, GPS coordinate logging, and then we also did a systematic census of a defined study area. So our primary site of research was the National Mall. That's where we did both of our case studies, and that's where we did our census. The National Mall is a particular area of high cone density, and as it's a public space, it's really easy for the team to access. So our data collection workflow. So when we would go out to the field, first we would do our site visit, then we would have our observation, we would document that observation, then we would geolocate that observation, and then we would add that to our archival record. So research ethics, we spent a lot of time thinking about this, and our ethical framework is rooted in our commitment to observe without disturbing. And so we have a strict non-contact observational methods that we apply. and we only document our subjects as we encounter them. And at all times, whenever we go out to the field, we are always cognizant of the fact that we are stepping into their environment, their habitat. And collectively, these practices both ensure that we respect our subjects, but also ensure the integrity of the data. So once we had our ethical framework in place, we were ready to head out into the fields. And as I mentioned earlier, we did two case studies in the census. Our first one documents subjects at a fixed site. The second one, we tracked the movements of an individual subject. And then lastly, we did a full census of the Smithsonian corridor on the National Mall. So case study one, we were at the National Mall for that, and over here is going to be the Capitol, there is going to be the Washington Monument, and our main area of interest is here for Site 2. So this is our first documentation at Site 2, and what struck us about this is you will notice that there are a total of 6 cones here. This one here is in the center of what was a street light post that has since been removed. Then we have these 3 cones that are connected with cone connectors, and we have 2 cones that are also in close proximity over here. And what struck us about this is this is clearly a 1-cone job, but we have a rather intricate formation. And 12 days later, we found that those 2 unconnected cones, we're seeing from a different angle, are gone. We then returned 52 days later. Shockingly, that individual cone in the center is gone. We did have a bit of a gap in our data. It was 140 days later before we had our next documentation. So whatever occurred at that site is unknown. However, we do have a cone that is in that recess now, but this is completely different from the original 6 that were there. 80 days later, we did return to see what was going on at the sites, and that is still the same cone, however, it was tipped over. And then when we returned 33 days later, that individual had returned to the recess streetlight. So findings here, so we watched the population decrease from 6 to 4 to 3 to 1. And our final recorded individual was not among the original 6. The population and configuration changed each of our visits. And the timing of those movements is unknown due to we were just going at individual moments in time. And we also have no idea where those original 6 ended up going. Case study 2, sequential observations of subject 3C. So we're back at the National Mall. Here we were over here for Site 2, and our primary research area is going to be over here. This is the Smithsonian Castle. So here's our first observation of subject 3C, which is this drum cone here. The team has named this cone Beaky. And as you can tell, Beaky has a very unique denting on both sides, which enabled us to easily track him around the mall and distinguish from other cones. So we next saw him 53 days later, and he had moved 63 feet. We next saw him 64 days later, and he had moved a total of 378 feet. After that, 96 days later, 63 feet of movement. And then 72 days later, we had a movement of 18 feet. And this was our most recent documentation of Beaky. That was 19 days later, and a movement of 23 feet. And so just to show you what that looks like on the map, here is our original starting location, second location, big jump there. We're finding for case study 2. So we documented Beaky over the course of 305 days and have 16 location sites. And of the 6 observations I showed you, just to get a sense of the movement that happened, that was approximately 518 feet from the 6 that I showed you. However, the timing, frequency, and any movement that might have happened in between our individual recordings remains unknown. So as you can maybe tell by now, there are some limitations from our case studies. Because we are limited to documenting at individual moments in time, we don't have access to data around continuous movement. And any sort of, the timing and frequency of the movements, as well as any movements in between, remains unknown. And if we are going to, identify movement and behavior patterns, we will need to have continuous GPS tracking data. So we are still committed to a tag and release study. Now for the full census of the mall, here we are at the mall, and this is our defined study area. Again, that's the Smithsonian corridor. And that's about 166 acres with a perimeter of 2.31 miles. And so over the course of our census, we counted 502 cones. The vast majority of those were recorded over the course of 6 hours. We did have 2 subsequent site visits where we recorded a few additional cones. And based on where those cones were when we located them and what we had in our records, we're confident that those were not recorded previously. So here's what 502 cones looks like. And to give you a sense of kind of the distribution of cones, here are kind of the clusterings that happen. You can see that there are some sparse areas as well as some denser areas. And so we took that there was an area of particular interest for us, and that was this very dense area here. So we wanted to take a closer look. Here we are again by the Smithsonian Castle, and we are particularly interested in this area here. So this is our area. We found 61 cones in 0.01 acres, very cone dense. And to give you a sense, this is what that looked like. So census findings. So again, 502 cones, 166 acre study. There was a lot of variation, as you saw on the map, in terms of where the density was and where clustering occurred. We now have a really awesome baseline population, and we're planning to do additional censuses so we can track how that population and distribution changes over time. So once we had done our case study 1, our case study 2, and then our census, we realized pretty quickly that in order to actually engage with the data and in order to analyze it, we needed to have descriptive frameworks in place so that we had standardized language, and that would also support future documentation. So the frameworks that we developed, first was taxonomy. It was really important to be able to distinguish the different types of cones. There's a lot of variation. Then variation in cone condition and appearance. Then we had cone groupings and behavior. And then lastly, environmental engagement. So the classic taxonomic classification of traffic cones. So there's currently 3 types of traffic cones that we recognize: standard cones, drum cones, and delineators. We'll start with looking at standard cones. Now, one might initially think that the variation in standard cones is related to the size, and they do vary in size, or perhaps it's the color. However, our system was built around the anatomical features that are built in at time of manufacture. So of the standard cones, we distinguish them by 2 different types of bases. So we have continuous base cones, which as you can see is continuous. And then we also have attached base cones, as well as detachable base cones. So for continuous base standard cones, there is the next point in our taxonomy that we look at is the foot type. First we have the hollow foot. We have partially hollow. We then have a protruding foot that has a smooth edge, a protruding foot that has a bit of a lip, and then we have our protruding ruffled foot. So there are also some variation in terms of the cone, the top types. We have a standard top here, which is smooth and continuous, and then we also have this loop top. So we'll take a look at a subspecies to give an example. So subject 126C is a 28-inch standard top ruffled protruding foot continuous base standard cone. Now I'll move on to attached base standard cones. And so first thing we look at with attached base standard cones is the seam types. There are 4 seam types that we've identified. The first is smooth seam, so we just have a nice little smooth seam here. Here we have a dotted seam. We also have an inverted dotted seam, which you'll notice is the same color as the base of the cone as opposed to the cone body. And then lastly, we have a square seam, which might be very hard to picture, but it is there. We've only recorded 2 of these out in the field, so those are very exciting to see. Points of variation on attached base top types. So we have a standard top again, as well as we have a boss type where it's a little tapering at the top before it flares out again. So for an example subspecies, we have subject 67C, which is a 28-inch boss top inverted dotted seam attached base standard cone. With regards to detachable base standard cones, those are not as common. We haven't identified as many of them. There is the variation that we look at is in terms of the base type. So first we have these rounded corners. We also have the hexagonal handle base types, and then lastly we have the short cornered octagonal bases. And as far as variation in detached base types, we have the bulb top, and then we have the boss top. For our example subspecies, we have subject 428C, a 36-inch boss top rounded corner detachable base standard cone. With drum cones, there is actually a lot of variation in drum cones. The first thing that we look at is the body type. There's rounded body, and then there's flat-sided. And the next thing that we look at is the variation in the cone top types. So here we have a flat top, here we have a channel top, oops, then we have a asymmetric flat top and a domed, asymmetric dome top. Now there is also a ton of variation in the the drum cone's handles and eyelet types. We have 2 that have trapezoidal shape. This one here has a bit of a grip you can't quite see, and this one has symmetric eyelets. This one is similar, but you'll notice that there's no handle or finger point. Here we have the next one is arched handle asymmetric eyelets, and then we have arched handle protruding asymmetric eyelets. And then lastly, we have a flat handle. We have with asymmetric eyelets, symmetric eyelets, and then we have protruding symmetric eyelets. Variation in drum cone foot types. We're still working to document these because oftentimes we notice traffic cones with bases attached to them. Here we have the straight edge foot. We have the lip foot. We have the scored foot. We have the ridged foot, and we have the octagonal foot. So for our example subspecies, a familiar face, so the greasy beaky. Beaky is a flat top trapezoidal grip handle, symmetric eyelet drum cone, foot type unknown. Now delineators, taxonomy of delineators. So we were surprised to find that there is a fair bit of variation in delineators. We first look at their body types, and here we have a tubular body. We have a tubular body with a cutout. We have a 5-tier body, a 6-tier body, and then we have a cone-shaped body, which this is the only one of these that we have documented, so the team was very excited to get that. All right, variation in delineator top types. We are also still working on documenting and indexing them. Here we have a flat bar top, we have a trapezoid top, arch top, undulating top, curved grip top, and then lastly the bulb top. So for our example subspecies, here we have subject 206, flat bar top, 2-body delineator with an attached hexagon base. So cone condition and appearance. Once we had defined our taxonomy, it was important for us to look at kind of the cone condition, the conditions of the cones, and note that in our field notes. So there's a lot of environmental wear that we observed. Some of it is just like a bit of dust and debris. Oftentimes we do get buildup of grime, and sometimes it's quite significant. We also do encounter a fair bit of UV damage, and sometimes that paired with heat. You know, the DC summers, they get to us all. Damage, we also have a lot of like impact and compression is one type of damage that we documented. So we have sort of like dings and dents. Then we have compression, we have crushing. And then we have flattened to a pulp. The next thing we'll look at is fracture and rupture. This is another category we have a lot of variation on. Here we have some kind of smaller cracking. Here you can see a little more extensive. Eventually the structure will give way. Sometimes entirely. And while the snowcrete brought a lot to all of us, the cones also took a beating too. So modifications, the next thing we want to look at is the cones are frequently modified. And so we define modification as anything that's like a permanent change to the cone itself. So that includes things like branding, which occurs after manufacturing. We also count the adding of reflective colors or googly eyes or marks as well. Here we have, this is going to affix to the sign, so that counts as, or the sign is going to affix to the cone, so that's also a form of modification. And then some of the modifications so cones also have attachments. Those are things that haven't added to the cone, but they can be removed. So we have a lot of functional ones, such as these cone connectors. Oftentimes caution tape is involved. Or we also have these white status buttons attached to those eyelets. And sometimes they get used in different functional ways as well. We also encounter a fair bit of attachments that don't have clear purposes for them. So cone grouping and relationship dynamics. So we developed our taxonomy, then we figured out how to kind of describe their condition, the way they wear over time. And it was important for us to start to develop language around the way that they group and relate to each other. So the first thing we did is the cone grouping types. We have solitary cones, we have stacked cones, we have adjacent, clustered, and dispersed. Now on to cone behaviors. This was one of our biggest frameworks that we really worked on developing. We have a category we call working cones, where they are serving a clear purpose that's readily identifiable. And we also have non-working cones, where the purpose is not readily apparent. We have supporting cones, ready to jump in, should they be called to action. And then we also, or supporting cones are more supporting, sorry, the on-deck cones are the ones that are ready to be called to action. There were also some nuances in observed behavior that we are still trying to figure out how to navigate. Here we have what appears to be a very intentional setup with these cones. However, the purpose of them is a little bit unclear. Sometimes cones appear in situations where it's not really certain if this is really necessary and that the tree root there is really marks itself as its own hazard. Other times we have situations where it seems as if the cone is not maybe fully up to the task at hand. Can you use a supporting cone? We also have situations in which, here we had what appeared to have been 4 working cones. This must have been connected at some point to this cone here. However, is this now, is it still working, or is this a supporting cone? We're still working on discerning those sorts of nuances. And then lastly, we encounter situations like this that we find very difficult to categorize. So environmental engagement, after we figured out language for the ways in which they relate to each other, it's important to think about how they relate to their surroundings. And we noticed some kind of consistent behaviors and tasks that they serve. One of them was filling. We also have covering, blocking, and then enclosing. Similarly, there are nuances in environmental engagement. So here we have a cone that is technically filling, but also covering. Here we have a cone where it is unclear if its intended purpose is to cover that light that is embedded in the ground, or if that is just a placement by happenstance. Here we have a cone that appears, a group of cones that appear to be in a blocking formation. However, it's unclear as if they are blocking on this side of the parking garage, or blocking on that side, or if they are just really at the waiting for deployment. And then we've also found circumstances in which cones will actually encircle their own. So continuing research, so we have big plans for where to take our research. We are only just getting started. One of the things that we really want to do is implement that tag and release study. We are actively working on securing some funding to do so. We also plan to do a follow-up census on the National Mall. It's been 6 months, almost 6 months since we did our first one, so it'd be great to see what changes might have occurred. We also really want to develop a field tracking app. This would enable us to help with our census, because the app that we use, we were able to pinpoint individual coordinates, but we weren't able to capture any data, like the species of cone, any markings or distinguishing features, or anything else that was relevant. We also are really interested in doing some outreach to local manufacturers and distributors. The manufacturers will help us better understand the ways in which cones are constructed and enhance our taxonomy that we've developed. And distributors will help us to understand the life cycle of cones, as well as their broader movement patterns collectively. However, we have had an unexpected development that has really changed our next plans for research. During our final observations of Beaky, this one I hadn't shown you before, we noticed that the construction in the area that Beaky was, there were signs that it was starting to wind down. On March 29th, we noted that the work materials had already been started to be packed up. And then by our May 8th visit, the fencing that had blocked off that construction area was gone. And on Friday, May 15th, when the team arrived on the site, we found this. So as you can see, what was once a densely populated side of the mall is now sparsely populated with standard cones. The team has not documented Beaky since May 8th, and given the overall decline in cone density in that area, we've arrived to the unfortunate conclusion that it is likely that Beaky is no longer on the National Mall. While his current whereabouts are unknown, we have been searching far and wide for him and not been able to track him down. So in response to this development, we are now shifting all of our focus to tracking down Beaky. We have plans to reach out to the Smithsonian, the administration of the Smithsonian Castle, see if we can connect with the contractors who might have been performing the work and might know about the whereabouts of Beaky. And as we continue to the search, we will be sure to update you all if we are able to find him. But in the meantime, I want to thank you all for your time and attention, and we will continue to keep you updated as the research continues.